Namaste and welcome. स्वागत है आज की इस चर्चा में, where we're embarking on a brand new journey. In your earlier years, science invited you to just be curious, to observe the world closely and figure out how things work. But as you enter the world of secondary science, हमारा सफर और भी गहरा होने वाला है. We're actually shifting our focus from just what we know to how we know it. In this explainer, we'll be looking at how observations turn into precise measurements, how we build models to understand complex systems, and exactly how ideas are tested. So get ready to upgrade your scientific toolkit.
To really grasp this new approach, we need two core tools. On one side, we have the magnifying glass. This represents gehri nazar, or careful observation. It's all about noticing patterns and paying attention to details we might otherwise completely miss. But observation alone just isn't enough. We also need the compass, which represents sahi disha, or proper direction. This means asking the right questions and choosing the right models. Honestly, science needs both gehri nazar and sahi disha to ensure we aren't just wandering aimlessly, but actually making sense of our world with a real purpose.
आज के इस सफर का नक्शा बिल्कुल क्लियर है. We are going to unlock 5 key tools in our map for exploration. Making sense with models, यानी हमारी सोच, maths की भाषा, the frameworks of laws and theories, the power of estimation, and finally, connecting the branches.
Okay, let's dive into this. Tool number 1. Making sense with models, yani hamari soch. So Prakriti, or our natural reality, is incredibly complex. Studying a system in its absolute, full detail is often, practically impossible. So what do scientists actually do? They deliberately build simplified models. Let's ask a highly relatable question to understand this. क्या गेंद boundary पार करेगी? Imagine a cricket ball being smashed high into the air for a 6. If you wanted to build a simple scientific model to figure out if it will cross the boundary without hitting the ground, you have to decide what variables matter and what absolutely doesn't. To answer that question, we deliberately ignore certain details. The brand of the bat, the color of the grass on the field, or the stitching of the threads at the seam. इन सब चीजों से कोई फर्क नहीं पड़ता. We only keep the mass of the ball, the speed, and the direction. You see, ignoring details isn't a mistake. It's a deliberate choice to keep things simple enough to actually find answers. For instance, the famous Indian physicist Meghnad Saha didn't try to model every single atom in a star. That would be impossible. He simplified stars by treating them just as hot gas, which brilliantly allowed him to explain how a star's color connects to its temperature.
Moving right along to tool number 2, math, the language of science, ya bhasha.
For a lot of us, math can feel a bit intimidating, almost like a hurdle you have to jump over. But in science, math कोई रुकावट नहीं है. ये तो science की भाषा है. It's a highly precise, shared language that allows scientists around the world to think clearly and build ideas together. And the cost of not speaking the shared language correctly, it can literally be terrifying. Imagine a passenger aircraft running 15,000 liters short of fuel mid-flight. No way, right? But it happened. Why? Because the ground crew miscalculated the fuel required. They used the density of fuel in pounds per liter instead of kilograms per liter. This simple unit mix-up left the plane dangerously short on fuel, forcing a terrifying emergency landing.
And that story is exactly why we rely on standard units, Yamanik Igaya. Whether you're just buying a kilo of rice from the local market, or you're communicating complex scientific data to a lab on the other side of the planet, agreed international standards ensure fairness and avoid those disastrous errors. They allow scientific results to be universally compared without any ambiguity whatsoever.
Next up, tool number 3, laws, theories, and predictions. These are the niyam, or the frameworks of science.
Now, what's really interesting about this slide is how it breaks down something we constantly mix up. As observations are repeated and measurements are refined, scientists systematically organize their understanding into niyam, or frameworks. But what's the actual difference between a law and a theory? Well, a law describes a regular pattern observed in nature. It tells us what happens, kya hota hai, like Newton's laws of motion explaining that sudden jerk you feel when a bus stops. A theory, however, goes a step further. It explains why those patterns occur based on gathered evidence, kyu hota hai, like the atomic theory explaining how molecules are formed. Remember, a theory in science is never just some random guess. It is a solid explanation based on rigorous testing.
And the ultimate superpower of these laws and theories, it's the ability to make predictions. Predicting the weather tomorrow, or how far a kicked football will travel, before the event even happens. These are reasoned expectations based on solid evidence. But here's a crucial point. What happens when predictions fail to match real-world observations? Scientists don't just ignore the failure. They re-examine their assumptions and improve their models. Failing predictions are not a weakness. They're actually science's greatest strength because they drive us toward a much deeper understanding.
Let's apply this scientific thinking to something you've probably seen scrolling on social media. Is eating food harmful during the solar eclipse? क्या ग्रहण के दौरान खाना हानिकारक है? We can easily debunk this just by asking simple, measurable scientific questions. Think about it. An eclipse is literally just a play of shadows. So we ask, does the temperature change significantly? No. Does food magically go bad just by being in a shadow? Of course not. By asking these measurable questions, we quickly see there is absolutely no physical, chemical, or biological mechanism supporting this viral myth.
Let's look at tool number 4, the power of estimation. Yul Prayog.
Let's move to and see how this builds. In science, exact values aren't always necessary right away. An andaza or rough estimate is often enough to check whether a result is reasonable or completely impossible. Science actually values this careful reasoning way more than purely accurate calculations, so let's try it. How much air do we breathe in a single day? Instead of panicking over some complex formula, let's just estimate. Step 1. At rest, we take about 12 to 15 breaths a minute. Step 2. There are 1440 minutes in a day, meaning roughly 20,000 breaths daily. Step 3. What's the volume of one single breath? Well, think of a party balloon. It takes about 4 to 5 breaths to fill a 2-liter balloon, so one breath is roughly 0.5 liters.
Multiply that out, and you get a massive 10,000 liters of air per day. Now, the goal here isn't decimal point perfection. It's to check if the scale makes sense. It's exactly like estimating how much rice a family of 4 needs for a month based on their daily diet. Estimation beautifully connects scientific thinking to our everyday reality.
And that brings us to our final tool, number 5, connecting the branches.
As you go deeper into secondary science, your subjects will split up into physics, chemistry, biology, and earth science. But it is so vital to remember that these boundaries are made by us just to organize human knowledge. Nature has no boundaries. प्रकृति की ऐसी कोई सीमाएं नहीं है. To solve the real-world problems today, we desperately need an interdisciplinary approach. Think about the COVID-19 surgical mask on the screen. Making something this common and vital actually requires ideas from several different disciplines working seamlessly together.
Just think about it. Physics tells us about particle motion and the electrostatic attraction needed to actually trap particles. Chemistry helps us understand the specific properties of the polymer fibers used to weave the mask. Biology is absolutely essential to know the size and behavior of the viruses we're trying to stop. And math? Well, that's used for modeling airflow and filtration efficiency. All these branches connect to give us a simple, everyday solution that literally saves lives.
As this quote reminds us, science is not just a dusty collection of cold facts or rigid equations. It is a deeply human activity, shaped by curiosity, creativity, collaboration, and careful questioning. It's an ongoing journey of learning how to understand the world. तो चलिए निकल पड़ते हैं इस नए सफर पर. Happy exploring, but before you go, I want to leave you with a quick thought. The next time you see a dropping apple, a falling leaf, or a passing cloud, ask yourself, which branch of science does this belong to?